Hello, Sahib. Hello, Nimra.
Hello, good morning, ma'am.
Good morning. How are you?
I'm good. What about you, ma'am?
I'm fine, thank you. Hello, Halima.
Assalamu alaikum, ma'am.
Walaikum salam. How are you?
I'm fine, ma'am. How are you?
Fine, thank you. Nimra, are you there?
Yes, ma'am.
Acha, I called you out. You didn't speak.
I hear your voice.
Okay. Hello, Nashram.
Hello, ma'am.
How are you?
I'm fine, ma'am.
Good. So let's wait 1 minute and then we start, okay?
Okay, ma'am.
Hello, Eliam.
Good morning, ma'am.
Good morning. How are you?
Fine, ma'am. Ma'am, how are you?
Fine, thank you. So what were we studying last time? क्या पढ़ा था हमने? Yes, who would like to do a small recap? Yes. Think about it. I'll take your attendance meanwhile. Okay, Ahmed Hassan is not there. Fahad bin Ahmed is not there. Hafiza Aisha is not with us. Ali Musa, Manur Amjad, Nimra Arif.
Present, ma'am.
Okay. Syed Azad Asad, Farooq Ahmed, Muhammad Awais Gill. Okay, Laiba, Sahib,
Yes, ma'am.
Nashra.
Present, ma'am.
Okay. Halima, Aruba, Maham,
Present, ma'am.
Maham, Aruba, Halima,
Present, ma'am.
Nawab Sadiq, Siddiq, Sumabi Tahir, and Saul Rafaqat. Okay.
Ma'am, Elia Shafkat.
Okay, Leah. Okay, so what were we studying last time? Can you tell me a little bit about it? Yes.
मैम आपने लास्ट टाइम 2 वीडियोस दिखाई थी जिसके अंदर हमने हाउ आमना महम
Amna Maham. Yes.
मैम आपने हमें वीडियोस दिखाई थी जिसके अंदर एक में तो ये था कि यूनिवर्स का कैसे बनी बिग बैंग थ्योरी थी और उसके अलावा कि वर्ल्ड एक्सपैंड कर रही है ये बताया था और दूसरा हमने की दूसरी वीडियो में की थी एटम्स और इलेक्ट्रॉन्स के ऊपर थी उनकी फॉर्मेशन के ऊपर उनकी बॉन्डिंग के ऊपर
एक मिनट ओके ये सामना दोबारा बोलना
मैम लास्ट क्लास में हमने 2 वीडियोस देखी थी जिसके अंदर हमने बिग बैंग थ्योरी यानी कि वर्ल्ड कैसे बनी और उसके बाद हमने ये देखा था कि वर्ल्ड एक्सपैंड कर रही है और ये और
I want to write the so we talked about the Big Bang, right? और हमने बात की थी about the what else?
और मैम हमने दूसरी वीडियो एक देखी थी जिसके अंदर हमने इलेक्ट्रॉन्स और एटम्स और मैटर के बारे में बात की थी कि हर चीज़ मैटर से बनी है और सबसे छोटी चीज़ एटम है और उसके अंदर भी इलेक्ट्रॉन्स होते हैं इलेक्ट्रॉन और के अंदर जो है ना यानी कि न्यूट्रॉन प्रोटॉन और उनके जो फोर्सेस थी अपवर्ड फोर्सेस और डाउनवर्ड फोर्सेस जो कि उनको जोड़ के रखती है आपस में और ये सारा स्ट्रक्चर हमने पढ़ा था फंडामेंटल स्ट्रक्चर जो था इसके ऊपर हमने बात की
We talked about the fundamental particles of matter. We talked about the forces. We talked about ये सब कुछ हमें स्टैंडर्ड मॉडल में पता चलता है ठीक है ना the standard model describes this and yes fundamental forces कितनी है कोई भी आंसर कर दे it's fine thank you आमना कितनी होती है fundamental forces yes how many fundamental forces you have
मैम ग्रेविटेशनल फोर्स वगैरह ग्रेविटेशनल फोर्स इलेक्ट्रिक फोर्स और मैग्नेटिक फोर्स होती है
उसको हमें कंबाइन करके कहते हैं इलेक्ट्रोमैग्नेटिक फोर्स राइट
यस मैम
और
मैम एनर्जी फोर्स हो सकती है
नॉट रियली स्ट्रॉन्ग हमने बात की थी ना स्ट्रॉन्ग न्यूक्लियर फोर्स ठीक है एंड वीक फोर्स ठीक है ओके सो
यस
तो वी विल कंटिन्यू आपने चैप्टर पढ़ा आप लोगों ने आप लोग उससे परेशान नहीं होना डोंट बी स्केयर्ड ओके these are very interesting concepts like I told you before many sci-fi movies are based on this and you don't really need to be a physicist to understand those movies even children can understand them and enjoy them so astronomy cosmology these have been topics of a lot of videos of a lot of sci-fi movies of a lot of documentaries there are many TV shows about these. So you can enjoy these topics. Actually, they're very fascinating and you don't need to know a lot of physics to understand them. Okay? So even basic school children can understand them. So again, please study your chapter. So the first thing for preparation for this case is you study the chapter. Okay? That's always the first thing. Again, don't be scared of the number of pages, because you're not expected to memorize them. You're expected to understand the main concepts. So it doesn't matter, if there are many pages. Again, when you study this, you might see some new terms, okay? But we are discussing those terms, and if there is something you don't understand, you can always look it up. Okay? And after this, we are also watching some videos. The videos also help understand some concepts, and then we will apply this concept to solve small problems, right? So you look at the examples in the book. So this is the pattern of the problems that we will be solving. The examples in the book, again, these are solved. So but you have to first understand them, then you close the book and then solve it yourself. We will also practice this in class. We'll practice some of them. And then I will also make small MCQs from this chapter. So this is how you can prepare the chapter. It's very simple, very easy. Of course, you will study the material that is being uploaded. And in addition to that, for your own curiosity, for your own interest, you can watch as many videos or shows as you like. So it's always a very fascinating chapter, topic, like I said, and many people take astronomy as a hobby. If you want, if there are many events that take place. Even in Lahore, you have these telescopes where you can go and watch the sky and look at the stars and the patterns and all that, and try to identify them. Also, you can have softwares or apps that you can install that give you a live view of the sky at different places in the world, and they can help you also understand them and identify them. That's just for your curiosity. It's not from the examination point of view. I'm just telling you as a hobby if you want to do it. And also, you can visit NASA. NASA has a lot of interesting material. Again, this is not very, you don't have to go into the advanced material. You can look at the simple material that they have designed even for children. You can see some very interesting, beautiful images of different phenomena that are taking place in the sky. So even many of us use these as wallpapers, as desktop backgrounds. They're very beautiful and very fascinating. It actually shows you how physics is related to everything in this universe, starting from the biggest to the smallest. You see, these particles are the smallest particles one can think about, so the fundamental particles. And then we talk about the cosmos, the universe, the stars, the sun, the planets, and those are very big bodies, right? So physics is involved in everything. So it's fascinating. Don't be scared. It's not about the exam. I'm just telling you, the different ways in which you can have fun with these topics. From the study point of view, from the examination point of view, you can use this approach, right? You first study the chapter. You always first start from the chapter, the text you have. To supplement that, you can watch the videos. Of course, you can watch the videos that I have uploaded. Plus, you can also watch additional videos if you're interested, of course. And then you start practicing the examples in the chapter, okay? We'll also practice them in class, and then I will also practice some MCQs with you later after the holidays, okay? So the example problems, the problems again that will come in the exam will be similar to the example. And the MCQs will be small MCQs based on these concepts that we are studying. Is that clear? ठीक है?
Yes, ma'am.
हाँ, तो इसमें डरने वाली कोई बात नहीं है. Again, like I said, physics is not something that you memorize. It's something you understand and then you apply. We understand the concepts and then we apply those concepts to solve problems or to answer questions. Okay, so that's how we are going about this. Now I'm going to share the book with you. Okay, and like I said in the beginning of the course, take a printout of the chapters of each chapter, because you know that it's easier and you can focus more. It's good for your concentration as well to study from a printout rather than to just look at your mobile phone. Okay, so print it out and then the first time you take an overview, you just read through it, and then the second time you start solving the problems, and the third time you start maybe making your own small comments and so on, and then you will be clear about it. So these are very simple, small concepts. Okay, it's nothing to be scared of. Okay. Now about the book, let me see. Let me share the book with you. You know that we have holidays, right? From Monday to Friday, right?
Yes, ma'am.
Yeah. So we will after the holidays, of course, we will start the regular classes, but you should also take care of the assessments that we have, right? The assessment plan was decided in the beginning of the course, and it has been communicated to you several times, right? So keep looking, mark it on your calendar and prepare accordingly, right? I've already discussed this with you in detail several times. So I just show you the plan, the assessment plan that we have. We have already, like we have covered the assignment 1, quiz 1, midterm, assignment 2, all this has been done. Now you're going to prepare for quiz 2. And quiz 2, as I said last time, is chapter 3 and chapter 4. So quiz 2 is chapter 3 plus chapter 4. So this will be on the 17th of May after the Eid holidays. The lab exam is on the 17th of June. For this, you have to practice the lab material. And about the lab exam, as I explained last time, the format of the lab exam is that one lab related question will be allotted to each student, right? So you will then write a report about it on the pattern of the reports that we were doing before. Okay, this will be a Word document, right? So this will be a Word document. This will be uploaded to Moodle. So of course, you should start preparing for this, because in fact you should have prepared regularly every week. Like I said, at least two hours per week you should spend on practicing the material that we have. And then you perform an experiment on one of the virtual links. You look at the problem that has been given to you and then identify which virtual link will be suitable for that. You choose one of the links that we've been using in the course, and you perform the experiment and make a small video with narration. With narration means you will explain in this video how you're performing the experiment. Okay, so every step will have marks. And for this purpose, I would ask you to practice using your device, which app, for example, you will use for recording the video, some screen recording, okay? And then which app you will use for compressing the video, because compressed video will be easy to upload to Moodle, okay? So these are the two things that you will upload to Moodle. Okay, so again, this will be a short video. It's not a very big video. We've been uploading many videos, but in your case, from the examination point of view, you also have to explain what you're doing in that video. So you will also have a narration. And then you will have the lab exam. The lab exam is chapter 3, 4, and 5. We decided the date for this as 28th of June. Okay, so you have enough time for practicing this. And then this is a 2 hours exam. The format of this exam is similar to the midterm exam. So you will do it in that way. You will have MCQs. These will be based on problems and or small questions, and you will do them in Moodle. Plus, you will also make a scan of your working and upload it. And you will also switch on your camera with Zoom while you're doing this. Is that clear?
Yes, ma'am.
Good. Okay, so now I'm coming back to the textbook. Okay, so now we are going to look at the topics which are nuclear reactions. Okay, um, so nuclear reactions, and then when we talk about nuclear reactions, we also talk about radiations, and the main radiations that we talk about are alpha rays, beta, and gamma radiations. The properties of these radiations, for example, their ionizing power, the penetrating power, the effect of magnetic and electric fields. So discovery of radioactivity, you can read about this. Some important names in this regard, for example, Bechdel was a scientist who played an important role in this. You can look at this. Then Marie Curie, for example, is also very famous. She got 2 Nobel Prizes. You know, getting 1 Nobel Prize is a big deal, but she got 2 Nobel Prizes. Again, her work was related to radioactivity, and she also discovered a new radioactive element. So some of these properties are given over here. You can see alpha radiation is represented by the symbol alpha, which is a Greek symbol, right? Beta is represented again with a Greek symbol, which is like this. Gamma is represented by a Greek symbol, which is like this. Okay. So alpha radiation is normally also known as helium nuclei. So you know helium is an element that has 2 neutrons and 2 protons. So this is the structure of alpha radiation, and it is ionizing radiation. Ionizing means when you have an atom, you have neutrons, protons, and you have electrons outside, uh, orbiting around outside the atom, right? So if this electron, the outermost electron, for example, is removed, then this atom becomes a ion. It becomes charged. So this is known as ionization. So alpha radiation can induce ionization, and it is not very penetrating. You can stop it with a piece of paper. Beta radiation are electrons. Again, you know, electrons are negatively charged particles. So these are charged particles, and in this case, their penetration power is higher than alpha radiation, but their ionizing ability is less than alpha radiation. Gamma radiation are actually photons. You know, photons are quanta of light. The electromagnetic spectrum that I shared with you last time, if you look at that, so a part of that spectrum is known as gamma. You know, you might remember that I shared the electromagnetic spectrum last time with you. Yeah, this is the visible spectrum. Okay. Not the visible spectrum, but the electromagnetic.
मैम
Yes.
मैम आमना हम अपनी ही तीनों को रिपीट कर देंगी
किसको?
अल्फा रेडिएशन बीटा रेडिएशन एंड गामा रेडिएशन
अच्छा, एक मिनट. Okay. अल्फा रेडिएशन जो मैंने आपको बताया ना, अल्फा रेडिएशन इज ऑल्सो नोन एज हीलियम न्यूक्लियाई. हीलियम का न्यूक्लियस. मैं अभी आपको वीडियोस भी कुछ शेयर करूंगी, ठीक है? आपको एटम का तो पता है ना, एटम का स्ट्रक्चर क्या होता है. एटम होता है, उसके अंदर क्या होता है, न्यूक्लियस होता है. न्यूक्लियस के अंदर क्या होता है, यू हैव प्रोटॉन्स एंड न्यूट्रॉन्स, ठीक है? तो उसका जो हीलियम, अगेन यू हैव द पीरियोडिक टेबल जिसमें डिफरेंट एलिमेंट्स होते हैं, लाइक हाइड्रोजन, हीलियम एंड सो ऑन. So this is helium जो है, it has the property that it has 2 neutrons and 2 protons. So ये अल्फा के बारे में मैंने कहा था, ठीक है? बीटा जो रेडिएशन है, these are electrons. Electrons you know are negatively charged particles, ठीक है? And gamma जो है, these are photons. Photons जो आपको पता है, सन से हमारे पास इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम आता है, ठीक है? उस इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम के कुछ वेवलेंथ को के एतबार से we divided into different you know a part of that spectrum is, लेकिन वो सारों की प्रॉपर्टी वही होती है, which is they are photons. Photons means light को का हम कहते हैं ना, हमने जिस चैप्टर में पढ़ा था कि लाइट जो है, it has the property of being it can behave like as a particle and it can behave as a wave. तो वो जब वेव के तौर पे बिहेव करती है, फेमिलियर विद दैट, रिफ्लेक्शन होता है, रिफ्रैक्शन होता है एंड सो ऑन। और जब वो पार्टिकल के तौर पे हम उसको कंसिडर करते हैं तो वी कॉल देम फोटॉन्स। फोटॉन्स आर पैकेट्स ऑफ एनर्जी, क्वांटा ऑफ एनर्जी, ठीक है ना। तो ये मैंने बात की थी इसके बारे में, ठीक हो गया।
यस मैम।
ये बोला। Okay. Again, I come back to the chapter. So यहाँ पे we have some explanation for these. ज़ाहिर है जो charged particle होंगे, they will be affected by a magnetic field. So this is a description of an experiment in which, for example, you can see that helium nuclei क्या होता है, उसमें protons होते हैं which are positively charged. It's deflected by the magnetic field. Beta जो है, these are electrons, they are again negatively charged particles, they are also deflected by the magnetic field. जबकि gamma जो है, these are not magnetic particles, ये photons हैं, उन पे charge नहीं होता and therefore ये straight जाते हैं, they are not deflected by the magnetic field. So this is just an experiment that explains these properties. यहाँ पे you can see them, you can see the explanation for them. Again, another topic that we talked about last time was fusion, nuclear fusion. तो एक होती है fission, nuclear fission, और एक होती है fusion. I've talked about this several times. So nuclear fission means the breaking up of a large nucleus, and this process releases a lot of energy, and this is the principle on which nuclear power is based. Pakistan also has nuclear power reactors. It's the source of energy. And then हमने शुरू में पढ़ा भी था, this is based on the very important and equation which is E is equal to mc squared, whereby matter can be converted into energy. I've explained this already. Now nuclear fusion is another concept which is the reverse of fission. In this case, small light nuclei are combined together, which means they fuse together. And again, in this process, there's a small mass difference that's converted into a large amount of energy. So we have in the beginning of the chapter, we have this formula and we have its explanation, and we also have a small example that shows how this energy can be calculated. So nuclear fusion, for example, there are two ways, for example, in which you can do this. So these are based on nuclear reactions. अभी शुरू में हमने nuclear reactions की बात की थी ना, तो these are examples of nuclear reactions. So one is called the PP cycle. PP means proton-proton cycle. So this is the combination of light nuclei like hydrogen plus hydrogen, and then they will combine to give you deuterium. So you know the isotopes of hydrogen, and it plus positron plus neutrino. And if you calculate the energy, it comes out to be 1.44 MeV, mega electron volts. Again, how this calculation is done, this is explained in the beginning of this chapter. There's also an example in which this is calculated for one of the reactions. Okay. So these are examples of PP reactions. And again, this is also possible with carbon, nitrogen, oxygen. So this is the second type of nuclear reactions. And in this case, you can see that you have these reactions. Okay. So you can study these in details again about the stars and the sun. The sun, you know, is a very important part of the universe, right? It is the source of energy in this universe. We would not have been able to, there would have been no life on Earth if there was no sun. So the sun is also a star. It provides light, heat, and energy that support life on the Earth. And how is this energy generated? It's generated by the process of nuclear fusion. So here you can see again some explanation about this, and here the sun has been described in more detail. The central part of the sun is known as the nuclear core. This is where the nuclear fusion reactions are taking place and generating energy. The second layer is known as the radiative core, and the third layer is known as the convection zone. You know that for life to survive, we need a certain temperature. So this heat, our source of heat is coming from the sun. Also, the sun has an atmosphere like the earth has an atmosphere, and the various parts of the atmosphere of the sun have been labeled over here. You have the photosphere, the chromosphere, and the corona. So these are also described here. Another thing about the sun is the sunspots. The surface of the photosphere also appear. There are some spot-like structures that we call sunspots, and these appear as irregular dark areas with a central core and a brighter border like this. And the darker central umbra has a temperature of about 4500 Kelvin. It has a very high temperature compared with the brighter surroundings at 5000 Kelvin. So you can again read about this. Then you have an explanation for the chromosphere and the corona. The corona is the outermost layer of the sun's atmosphere. It extends from the top of the chromosphere to several hundred million kilometers from the sun, where it gradually becomes the solar wind. So these are again things you might have heard of in your, in general life as well. So the sun is not a stable star, it varies. The activity of the sun is primarily a measure of the number of sunspots visible on its surface. Observations of sunspot numbers have been kept since the first telescope was turned towards the sun. But remember, it is dangerous to look directly at the sun. You never look at the sun directly. Okay, so if you're playing with astronomy, you should know safety rules as well. Okay, so this is again a diagram that illustrates the concept of the solar wind. Right, and now I can share a video with you. Okay, so that's explaining this. Let's look at it. Yeah, so
मैम क्लास एंड होने में 6 मिनट रह गए, हमने रीजॉइन करना है?
नहीं, आपने रिजॉइन नहीं करना। मैं ये वीडियोस के लिंक्स आपको दे दूंगी, आप वहां से भी देख सकते हैं। ठीक है,
ओके मैम।
And welcome to our universe. Today we'll be answering the question, how does the sun...
Can you see the video?
Yes, ma'am.
ठीक है,
...produce energy? So we've all seen the sun burning bright in the daytime sky, unless you live in England. But people don't quite question, where does the sun get all its energy from? I mean, we know right now that our sun isn't some kind of fire in the middle of the solar system. So what is powering this massive sphere that holds all the planets in place? So the sun contains most of the mass in the solar system, and this is quite critical. The parts from all the planets, because it's the only object in the solar system where nuclear reactions are really occurring. So what exactly is a nuclear reaction? Under extreme conditions, it is possible for several atoms of one type of element to merge together to form a different element. And it's also possible for a single atom to be broken up into several individual.
ओके, यहाँ पे यू कैन सी ये यहाँ पे ये फ्यूजन है और ये क्या है, ये फिशन है. यहाँ पे you have small atoms combining together to make a bigger atom, और यहाँ पे you have a bigger atom breaking into smaller atoms. ठीक है?
Atoms. These are all known as nuclear reactions, and there are two types: the fusion reactions and the fission reactions. These nuclear reactions can release a large amount of energy. The total mass of the atoms weighs slightly less than what they did before the atoms went into the reaction. This extra mass is converted into energy, and this is what we see in the equation of E equals mc squared, where E is the energy and m is the mass, and c is the speed of light. Since the speed of light is a very large number, even a small amount of mass can result in a large amount of energy. Putting two small atoms together to make one bigger atom releases energy, and this can happen to the mass of an iron atom. The fusion of smaller atoms is what produces the energy in stars, like our sun. And splitting apart a bigger atom to make two smaller atoms releases energy for atoms that are more massive than iron. This fission of large atoms...
Okay, you can see कि ये bottom में part पे जो this figure is the figure of a nuclear power plant. So a nuclear power plant is based on the concept of fission. ये जो a bigger nucleus breaking into smaller nuclei. And then you convert the mass into energy and you get a big amount of
energy. Is what produces the energy in nuclear power plants. This means that low mass atoms release energy by fusion reactions and higher mass atoms release energy by fission reactions.
So you can see that fusion is based on the combination on the fusing of small nuclei like hydrogen, helium, carbon. हमने ये बात की थी ना अभी. And fission reactions are the breaking of heavy nuclei like, for example, uranium. You can see ये number जो ऊपर है U235. 235 means this is the number of neutrons and protons. ठीक है ना? This is a huge number. जबकि hydrogen में you have only one proton and you have only one electron. ठीक है ना?
The iron atom seems to fall between these two groups.
And this is iron. Iron जो है ये इस binding energy के curve पे middle में आता है. It's a stable element. ये break नहीं होता ना ये fuse होता है. ठीक है?
This is because no nuclear reaction involving iron can release energy. However, you can't quite expect nuclear reactions to occur so easily. To understand why, we need to know how the atom is actually structured.
So this is जो मैं atom का बता रही थी ना, the central part of the atom is known as the nucleus, and inside the nucleus you have the protons and the neutrons. So one color is for the protons and one color is for the neutrons. And outside the nucleus, so the nucleus is positively charged because protons are positively charged particles, neutrons are neutral particles. And outside the nucleus, you have electrons that are orbiting, and the electrons are negatively charged.
So inside the atom, we have protons and electrons, and these have a property called electric charge. Electric charge can come in two different signs, positive and negative. The protons are positive charge, and the electrons are negative charge. There is also a fundamental force in nature which acts as an attractive force between objects with an opposite charge, and also has a repulsive force between objects with the same charge.
So particles that are charged, they experience the electromagnetic force, right? Well, you know that like charges repel each other and unlike charges attract each other, right?
So in an atom, the electrons are held to the nucleus by the electromagnetic force. But inside the nucleus, all the protons have a positive charge, but they manage to stick together despite the repulsive electromagnetic force. This is because there is another fundamental force that is taking charge, and this is called a strong nuclear force. This holds protons and neutrons together, and this force is stronger than the repulsive electromagnetic force between the protons. This only happens if two protons are brought very close together, and the only way to get protons in different atoms close together is that the strong nuclear force must overcome the electromagnetic force. This means that it allows two nuclei to stick together. This basically looks like the two atoms have collided at very high speeds. The nuclear reaction in our sun is probably most known as the proton-proton cycle, in which 4 hydrogen atoms are combined in a series of reactions to form one helium atom. This question, where does...
Okay, you can watch the remaining later on.